Hi, this is Suchadata teaching economics to class 11, and here I am with the 6th chapter of statistics of class 11, and the name of the chapter is measure of dispersion. Now the first question is that what is measures of dispersion? And the simple answer to this is that measure of dispersion is a measure of variation items, that is measuring the variation of items is called as the measure of dispersion. And when we do this, the importance of it is, that is why should we have the measures of dispersion? For that you must know that we have to find out about the variation, we have to know about the composition of the series, we have to know about the range of the values, we have to compare the disparity, and we have to find out the central tendency if at all it is representing the true value. So, in this measures of dispersion that we are going to deal in this chapter, we need to understand that we will be looking at the tools which are required for measuring the variation in the items. And as I said, we have to find out the variation, that is the highest range and the lowest range. We have to find out about the composition of the series as to how it has been framed, whether we have given some importance to the extreme values or we have composed it in a different manner, and we have to know about the range of the values. We have to compare the disparity, that is how much is the highest and how much is the lowest, that is the variation that we will try to find out by the various measures of dispersion. And we always take out the central tendency while doing this act, and if at all it is representing the true value. These are the objectives of studying the measures of dispersion. When we are studying the measures of dispersion, there are two things that you must know, and those are, we have first of all the absolute dispersion and the relative dispersion. This absolute dispersion is when we express it in the original units, that is 2, 4, 6, 8, 20, 40, 40,000 and so on. But the relative dispersion is when it is expressed in relative value, that is we can say in terms of percentage. So, in this chapter we will be dealing with the measures of dispersion, their importance, how it is calculated, and how it is an important statistical tool is the importance of studying this chapter. Now let's study about the methods of measuring the measures of dispersion. And as we learnt in the previous clipping that there are two methods of measuring dispersion, which are the absolute measure and the relative measure. In the absolute measure, we take the unit as it is, but in the relative measure, we take it in relative form, say could be in percentage. As far as the methods are concerned of the absolute measure of measuring dispersion, they are range, quartile, mean deviation, standard deviation and the Lorentz curve. But when we talk of measuring it in relative terms, then it is coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. Now this means that whenever we find out the measure of dispersion, that is we measure it, that is the time we need to find out in both these terms, both in absolute measure and the relative measure. So the first method that we must know in measuring the measures of dispersion is the range. Range is in fact when we find out the difference between the highest value and the lowest value in a series. That gives us the range. That is simple range of the absolute measure. Now the formula will be, as I said, highest value minus lowest value. Now I have taken up a series, say 20, 30, 40, 50 and 100. When I pick up this series and I want to find out the range of this series, what I am going to do is I am going to find out which is the highest and which is the lowest range or which is the lowest unit in the series, and that is 100 is the highest value and 20 is the lowest value. So the range will be 100 minus 20 giving me 80. 80 is the range of the series comprising of 20, 30, 40, 50 and 100 observation. But when I have to find out the relative measure, that is the coefficient of the range, what I am going to do is I am going to apply the formula which says highest minus lowest value upon highest plus lowest value. We already know the highest and the lowest value 120, which means 100 minus 20 upon 100 plus 20, which will give me 80 upon 120 and giving me 0.67 as the coefficient of range. So first of all, we have learnt in this clipping that there are 5 methods of the measures of absolute measure of dispersion, and when we find out these in the relative term, they become coefficient, whether it is coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, of standard deviation, and of course Lorentz curve is there only in the absolute measure of dispersion. In the next clipping, we are going to learn about the second method of measuring the measures of dispersion, which is called as the quartile deviation. Now we will be learning about the second method of measuring the method of dispersion, and that is the quartile deviation. First one was range and this is the second one, quartile deviation. When we have to find out the quartile deviation, it is in fact the difference between the third quartile and the first quartile. That is called as the interquartile. So a quartile deviation is quartile 3 minus quartile 1. Now again, to explain this further, we will take a series comprising of 11 observations and their numbers shall be ranging from 10 to 60. That means I have to find out, if I have to find out the quartile deviation, I will have to first of all find out the third quartile and the first quartile. So the third quartile, when we try and find out, it is Q1. If I am trying to find out, it is number of observation plus 1 upon 4, which means 11 observation plus 12 plus 1 upon 4, and this is the third item. Which is the third item here? 1, 2, 3, which means 20. Now let me find out the third quartile. The third quartile will be 3 number of observation plus 1 upon 4, which means 3, 11 plus 1 upon 4, which means the ninth item. When I have to find out the ninth item, it is 50. So I have both the third item and the first item, which is 20 and 50. So it is very easy for me to find out the quartile deviation. The quartile deviation here will be simple, Q3 minus Q1 upon 2, which means 50 minus 20 upon 2, which is 15. So, the quartile deviation of the series comprising of 11 observation from 10 to 60 is 15 by taking up the formula of Q3 minus Q1. Now, there is another, that is, we have to find out in relative terms, and when we try to find out the coefficient of the quartile deviation, the formula is Q3 minus Q1 upon Q3 plus Q1, and we already know both the Q1 and the Q3, which is 50 and 20. So, 50 minus 20 upon 50 plus 20 gives me 30 upon 70, coming to 0.43. So, this was the second method of measuring the measure of dispersion, and which is the quartile deviation. So, you have learnt the range and you have learned the quartile deviation, both the coefficient of range and the quartile deviation and the coefficient of quartile deviation. You just need to learn the formula properly, and for this, remember, it is just that you have to know the Q3 and the Q1 upon, and here it is the formula comprising of Q3 minus Q1 upon 2, and when we have to find out the coefficient, it is Q3 minus Q1 upon Q3 plus Q1, giving us both the coefficient of quartile deviation and the quartile deviation itself. In the third clipping, I shall be teaching you the third method of measuring the measures of dispersion. Now, let me teach you about the third method of measuring the measures of dispersion, and that is the mean deviation. When we have to find out the mean deviation, the steps which we have to keep in mind is that we have to first of all find out either the mean or the median or the mode of the series. Later on, we find out the deviation, and when we find out the deviation of the series, we ignore the positive and the negative signs. That is, we do not take into account whether it is coming in positives or negatives. That is the characteristic of finding out the mean deviation while finding out the deviation of the series. And to find out the mean deviation, the formula that we have to apply is total deviation upon the number of observations. Now, here I have picked up, say, n observations, that is 9 in number, from 1 to 9, and then the wages which these people get are ranging from 40, 42, 45, 47, 50, 51, 54, 55 and 57. This is the given series, that is a number of workers n and the salaries or the wages which they get is this. Now, what I have to find out is the deviation, as this is the second step, as I said, involved, and this I am trying to find out through the median. Okay, I am trying to find out the mean deviation through the median method, and in this I will be finding out the deviation. And in order to find out the deviation, the formula which I have to apply is x minus m, which means I will have to find out the mid value, and to find out the mid value, what I do is the number of observation plus 1 upon 2, which gives me number of observation is 9 plus 1, 9 plus 1 upon 2, which means the fifth item. Now, the fifth item is here 50. Now, when I know the fifth item, it is very easy for me to find out the deviation. That means 50 minus 40 will give me 10. 50 minus 42 will give me 8. Now, here what I am doing is I am not trying to include the positive or the negative signs, that is I am ignoring them. Now, Next is 50 minus 45 is 5, 50 minus 47 is 3, 50 minus 50 is 0, 51 minus 50, because we do not have to include the positives and the negatives. So 1, and 54 minus 50 is 4, 55 minus 50 is 5, 57 minus 50 is 7. Now what have I calculated? I have calculated the deviation, and when I have calculated the deviation, I shall find out the mean deviation through the median. So finding out the mean deviation median, the formula is here that we have the EDM upon 9, that is sigma dm upon 9, and the sigma dm, which means calculating this. When I calculate this, that is the deviation. When the calculation is done of the deviation, this will give me sigma dm. So 10 plus 8 plus 5 plus 3 plus 0 plus 1 plus 4 plus 5 plus 7 will give me 43. So I have the sigma dm. Sigma dm upon the number of observations. The number of observation is 9, which means 43 upon 9 is giving me 4.78. So here is the mean deviation median. But this is the first part of it, and everywhere I said that we have to find out the relative measure also, that is coefficient. So coefficient of the mean deviation median will be MDM upon M, which means the mean deviation median is 4.78 upon 50. That is the mid value that we have, 50 will give me 0.096. Once again, try to understand that when we were trying to find out the mean deviation, in this we find out through 3 methods, that is mean, median or mode, and to find out the deviation we must ignore the positives and the negative signs, and to find out the mean deviation we will calculate it by total deviation upon the number of observation. Here the series that we had was that there are 9 workers drawing this salary, and I had to find out the deviation, and to find out the deviation the formula which I used is x minus m. That means the mid value has to be calculated, and when I calculated the mid value by taking the number of observation plus 1 upon 2, it came to the 5th item, which means 50. So by ignoring both the positives and the negative signs, the deviation that I derived was this, and when I added up, this gave me sigma dm, which means 43. So I already have all that which is required to find out the mean deviation through median and the coefficient of mean deviation median. So mean deviation median is sigma dm upon n. Sigma dm is 43 upon number of observation n, and the coefficient is of mean deviation median is mean deviation median upon the mid value. So mean deviation median is 4.78 upon the mid value 50, which we calculated. So this was the third method of measuring the measures of deviation, called as the mean deviation. In the next clipping, I shall pick up the fourth method of measuring the methods of measures of dispersion. Now let's try and find out the fourth method of measuring the measures of dispersion, and which is called as standard deviation. The symbol or the sign of standard deviation is this, and the sum which we have got is the number of students are 10, that means the number of observations is 10, and the marks scored by them are 12, 18, 17, 13, 15, 9, 18, 11, 6 and 1. So if I have to find out the sigma x, I have to calculate the marks given here, which will be 110. Now next what I have to find out is the deviation. Here we have to take into account the positives and the negatives. We cannot exclude as we did in the previous learning. Here the deviation which I get is 1 minus 3, 6, 2, 4, minus 2, 7, 0, minus 5, minus 10. Now to find out the sigma x that we have, that is the standard deviation, we must see that we get it as 0, which means minus 3, minus 2, minus 5 and minus 10. 10 plus 5 15 plus 2 17 and plus 3 is 20. So in the minus that we have is 20. That means in the positives also we must have 20. 1 plus 6 7 plus 2 is 9 plus 4 is 13 and plus 7 is 20, which becomes plus 20, which means I derive the deviation as 0. But now we have to go further and we have to calculate the square deviation from here. When we calculate the square deviation, we multiply the term or the unit which has been given, which means 1 into 1 is 1, 3 into 3 is 9, 6 into 6 is 36, 2 into 2 is 4, 4 into 4 is 16, 2 into 2 is 4, 7 into 7 is 49, 0 is 0, 5 into 5 is 25, 10 into 10 is 100. Now this was the square deviation. Let's find out the sigma square deviation. We will calculate this 1 plus 9 plus 36 plus 4 plus 16 plus 4 plus 49 plus 0 plus 25 plus 100 will give me 244. So what you have in hand is the number of observation, which is 10, the sigma x as 110, the deviation score of 0 and the sigma x square, that is square deviation 244. Now I will try and find out the sigma bar, and to find out the sigma bar what we did here was the number of observations that we have upon that the sigma x upon the number of observation, which means the sigma x is 110 upon the number of observation, which is 10, which gives me 110 upon 10 is 11. Now next I must find out the standard deviation. To find out the standard deviation, the formula which has to be calculated is sigma x square upon n. And sigma x square here that we have calculated is 244, which means 244 upon the number of observation, that is 10, will give me 4.93. Now this was the standard deviation that we have calculated, but we have also to find out the next one, that is the coefficient of the range. The coefficient of the range will be the standard deviation upon x, that is the 4.93 upon 11, which will give me 0.45. So this was the method of calculating the fourth measure of dispersion called as the standard deviation. The fifth and the last method of measuring the measures of dispersion is called as the Lorentz curve. This Lorentz curve was actually studied and first used by a man called Max Lorentz. So hence this has been attributed to his name, and thus the curve has been called as the Lorentz curve. To construct this Lorentz curve, the method which we apply is, the first step is we convert the entire series into the cumulative frequency series. That is, supposing it is 0, 5, 10. So you are going to do 0 minus 5, 0 minus 10, and from 10 to 15 and 15 to 20 and so on. that is converting the series into the cumulative frequency series, is the first step which is involved in making a Lorentz curve. After this, we calculate this, or we draw this on the curve that we have, that is the cumulative frequencies are calculated on the x-axis and the cumulative items are calculated on the y-axis, which means the graph which shall be shown shall be x and the y-axis, and indicating, calculating both the cumulative frequency and the cumulative items on the x-axis and the y-axis. Now, both these axes, whether x or y, shall be calculated from the range of 0 to 100. Both the ways, x-axis as well as the y-axis, are calculated from x to 100 range. And after that, we draw a diagonal line which joins from 0 to 100. This diagonal line which is joined is called as the equality line. Thus, what have you done? First of all, you have plotted it in the x-axis and the y-axis by the series that we have, and thus the diagonal line joining the 0 to 100, and thus called as the equality line. When you observe the Lorentz curve, you will easily come to know whether there is less variation or the greater variation in the series, because if there is a closeness in the line that we have, it shows that there is less variation. If it is larger, the variation that we have, that is the space that we have, it shows greater variation. Thus, the Lorentz curve is dealing with both the change of the cumulative frequency on the plotting of the graph by x and y from 0 to 100 by a diagonal line, which indicates whether it has less variation or the greater variation by the closeness and the largeness that we have on the graph. And this Lorentz curve is used to show the income, wealth, wages, profit, the production and the population of a country or the world as such. This was the last method of measuring the measures of dispersion, called as the Lorentz curve. And now you all know that there are 5 methods of measuring the measures of dispersion, and also the first 4 methods that we have to have the relative measures of dispersion by the coefficient, and the coefficient, whether it is done in percentage or in some other relative term, is called as the coefficient of standard deviation, mean deviation, range, and so on. That was all about your 6th chapter of statistics of class 11. Thank you.